Okay, this is page 195, 196. Okay. So you have an 8-sided die, numbers 1 through 8. Now, meanwhile, you're trying to figure out how you make an 8-sided die. Don't worry about it. Probability that you throw an even number, this is A. You have 8 outcomes, 1 through 8, and the even number is 2, 4, 6, and 8. So reduce it, so you have a 1 and 2 probability. Probability that you roll less than a 7, so it's 1, 2, 3, 4, 5, 6. So there's 6 outcomes out of 8, which is 3 out of 4. Number 2, you roll a 6-sided die, and you try and toss a coin to get heads or tails. So your sample space is H1, heads 1, heads 2, heads 3, heads 4, heads 5, heads 6, tails 1, tails 2, tails 3, tails 4, tails 5, tails 6. So right now we know that there are 12 outcomes that could take place here. So this is answer for A is just a sample space. B is probability of rolling greater than 2 and a heads. Okay, so you want both of these events to take place. So I'm going to do this in a orange. So I'm going to look at heads, and I want greater than 2, so it's these 4. So 4 out of the 12 events reduced by 4, so you get probability 1/3. Letter C, probability of rolling greater than 2 or a heads. Okay, now that we're using the word or, so I have all of these events here, those are heads, and then greater than 2 or a heads. So I have these events as well, even though those are tails. 3, 4, 5, 6 are greater than 2. So you count them all up, there's 10 events out of 12, which is reduces to 5 out of 6. Number 3, roll 2 dice. So 1, 2, 3, 4, 5. 6 is 1 die. 1, 2, 3, 4, 5, 6. It's on the other. So our sample space is going to be this. Pardon me. Thank you. Sorry, my computer had goofed up, so I had to stop this and go again. All right, so this is my sample space. So this is for problem number 3 on page 195. So this is the answer to A. This is our whole sample space. For B, we want a probability of rolling a 4 or 8. So come up and take a look at our sample space. So I have 4, 1, 2, 3, and 8. 1, 2, 3, 4, 5. So there's 8 different outcomes that take place out of 36. Reduce that. So that's 4 out of 18, which is 2 and 9. That's my probability of rolling a 4 or an 8. Letter C. Probability of rolling a 6 on at least one of the dice. On at least one. So that could be both. All right, so let's think about this. I can have the 6 or the 6. 6, 6, 6, 6, and 6. Or I could go up the other way, so that's on that second die, or I could have these 6s here. So I have 1, 2, 3, 4, 5, and another 6, so I have an 11 out of 36 chance that takes place. Letter D. Probability rolling. Oh wait. I guess this was D right here. Let's do C. Rolling less than 9. So less than 9. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6. So I have 26 out of 36. So that's 13 out of 18. Letter E. Let's pick a color that we're not using. Use that bright pink. Letter E. Probability of even on both. Okay, so even on both. So even on both, 2, 2, 4, 2, 6, 2, 4, 2, 4, 4, 4, 6, 6, 2, 6, 4, 6, 6. So all the pink. Looks like 9 outcomes out of 36, which is 1 and 4. And then let's not worry about F. Go to the back side, page 196. Number 4. So you have a 4-sided die, so that's 1, 2, 3, 4. And then you have a 6-sided die, 1, 2, 3, 4, 5, 6. So these are all the outcomes. So 1 and 1 is 2, 3, 4, 5, 3, 4, 5, 6, 4, 5, 6, 7, 5, 6, 7, 8, 6, 7, 8, 9, 7, 8, 9, 10. Okay. That's our sample space. That's the answer to A. Our answer to B, rolling a 7. So you have 1, 2, 3, 4. You have 4 out of 4 times 6 is 24. So you have a 1 in 6 chance of rolling a 7. Letter C. Don't worry about C and D. Skip C and D. We're not going to worry about those. And we get to the cards. 5. So you have 52 cards in a deck of cards. You have ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. You have 4 suits. So you have hearts, you have spades, you have diamonds, and you have clubs. The hearts and diamonds are both red. These spades and clubs are black. All right, so letter A, what's the probability of getting a heart? Well, 13 out of 52 are hearts, so that reduces to 1 out of 4. B, probability of getting a heart or a diamond. Okay, so there's 26 of those cards out of 52, so that's 1 out of 2. Letter C, probability of getting a king or queen or jack. Well, there's 4 of each of these. So add those up, so I have 12 out of 52, reduce the fraction, that's going to be 6 out of 26, which reduces to 3 out of 13. Letter D, probability of getting a king and a queen. Well, there's no card. If you're picking a card, there's no king and queen, so it's 0 out of 52, which is 0. E, getting a king and red. Okay, so how many red kings are there? There's 2, so you have 2 out of 52, so that's 1 out of 26. F, probability getting black or red. So that's going to be all the cards, 52 out of 52, which is 1, 100% of the time. And G, getting ace or diamond. Okay, so there are 4 aces. There's 13 diamonds. But we don't want to double count here. Okay, I'm only going to use 3 of these aces because I have an ace over here. So that's going to give me 16 out of 52, which is 8 out of 26, which is 4 out of 13. All right, so that takes care of that. Don't worry about the rest of those problems on that page. But let's go to page 4-2. So this is page 82. All right, so the word independence. Okay, independence is a crucial concept in both probability and statistics, introduced for the first time. Okay, calculate the probability of multiple outcomes. So if you wanted independent events, so probability of A and B, that A has no effect on B. Okay, meaning like if I flipped a coin, and what's the probability of me getting heads and picking a king? Okay, probability of getting heads is 1 out of 2. Picking a king is 4 out of 52. Okay, the heads has nothing to do on the bearing of the king, so you just multiply that out. So in theory, when we're looking at stuff, if I have the probability of A and B, this little thing means and they are events that have nothing to do with each other. It's probability A times the probability of B. Okay, so example 1, flipping a coin 3 times in a row, obtaining all 3 heads. So probability of me getting a heads, and a heads. So it's 1/2 times 1/2 times 1/2, which is 1/8. Probability roll a die 5 times in a row and obtaining all 6s. So if this is your sample, just with a single die, probability of rolling a 6 and a 6 and a 6. You have a 1 in 6 chance, a 1 in 6 chance, and a 1 in 6 chance. So that's 1 out of 216. Okay. Oh, and I did 5 times in a row. That was only 3 times in a row. So if I had times 6, you'd multiply more, which that answer is no longer right. Use a calculator on that. And a free throw shooter throwing at 78%, what's probability that they get 3 at being a 78% shooter? So it's going to be 0.78 raised to the 3rd power. You move on from there. Okay, the complement, example 4 is pretty easy to read on page 83, but a complement is the probability of an event that happens plus the probability of the event not happening. So let's say you have a 3/4 chance that something happens. That means you have a 1/4 chance it doesn't. If you add these together, you get 4 out of 4, which is 1. That's what you want in these cases. Okay. So that's kind of doing toward the bottom. You can run through the example that's there. It's kind of a little goofy. And then it says, let's assume basketball player is successful making free throws 85% of the time. We just wanted to know the probability to miss one of his next 5 free throws. So you're going to go 0.85, which is the probability of 5 free throws. But I'm going to go 1 minus that. So I'm going to get 1 minus 44.4 or 0.444. Ignore that. So he has a 55.6% chance of missing one of his free throws. Okay, so this should help you along with the homework, which will be on page 197, 198. Have a nice day.